Hello friends, myself R.D. Mahajan presenting my video on Cauchy's residue theorem. Evaluate contour integral of z square into sine of 1 by z with respect to z over Cauchy, where that Cauchy is mod z is equals to 1 by Cauchy's residue theorem. And to evaluate it by Cauchy's residue theorem, first of all we determine the residue of this function by Laurent series. We know that sin x series as x minus x cube by 3 factorial plus x raised to 5 by 5 factorial and so on, and therefore we get the series for sine of z, sine of 1 by z, replacing x by 1 by z, we get that series as 1 by z as the first term, next minus 1 by z cube divided by 3 factorial plus 1 by z raised to 5 by 5 factorial and so on, terms alternately positive to negative. Then simplifying it, we get that as 1 by z minus 1 by z cube into 3 factorial next plus 1 by 5 factorial multiplied by 1 by z raised to 5 and so on. Then multiplying it by term z square. Therefore, we get z square into sine of 1 by z as z square multiplied by this series with the term 1 by z, next 1 by 3 factorial into 1 by z cube, next 1 by 5 factorial into 1 by z raised to 5 and so on. Multiplying inside this bracket by z square, we get the first term of that series as z. Next one is 3 factorial is 6, 1 by 6. Z square divided by z cube, we get 1 by z as the second term. Next one is 1 by 5 factorial. Z square divided by z raised to 5, we get that term as 1 by z cube and so on. This is that Laurent series. About the pole z is equals to 0, and therefore we get residue of that function f of z about the point z is equals to 0 as it is the coefficient of 1 by z. We have the second term as 1 by z. Its coefficient is minus 1 by 6. Its coefficient is minus 1 by 6. Therefore, that is the residue of that function at the pole z is equals to 0 by Laurent series. Here the first step is completed. I have obtained the residue of that function by Laurent series, and then we apply that Cauchy's residue. Then applying that Cauchy's residue theorem, we get the value of this contour integral, integration of z square sine of 1 by z with respect to z over that closed curve C as 2 pi I into sum of the residues. Here we have only one residue, and therefore substituting that value, we get that value as 2 pi I multiplied by that residue is minus 1 by 6. Just I have obtained that value, and simplifying it, we get that value as minus pi I divided by 3 as the answer or the value of that contour integral obtained by applying Cauchy's residue theorem. If you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.